All right, so hopefully the recording starts. Yep, there we go. And you should be able to see my screen. So here is the syllabus schedule. Just wanted to give everyone a reminder that the wait list ends on the 20th, so this Wednesday, tomorrow. We're already to the 20th of the month, and that is also your last day to add classes. So if there was any class you were trying to decide if you were going to add or not this semester, that is your last time to do it. We're getting further into classes, so it would be harder to catch up after that point too. Another reminder, we've got SmartBook Chapter 2. We should be able to get started with Chapter 2 content today, so that'll be good, and then hopefully you've already read the chapter for that as well. Let me know if you had any trouble with the SmartBook for Chapter 1, logging in, if you're still having troubles with Microsoft Teams or Canvas, so we can get that fixed sooner rather than later. All right, well, let's jump to our discussions on different kinds of research designs. Oh, that is a lot further than we were. So we finished off talking about a couple different study types. So naturalistic observation, just a quick overview again, is when you're observing as close to a natural setting as possible. A laboratory observation is where you have a more contrived setting. You've got some more control over variables, but it's still observing. You're still watching. You as a researcher or as a team of researchers are still watching a group to learn about them. In this kind of case, you might even make a very extravagant laboratory setting. So there was a group that I am aware of that essentially they were studying the interactions of a naval officer team. So both submarines and ships. So they brought in a whole team, basically the whole bridge of people, into just a room that they converted to look like a bridge of the ships that they were on. So they had the same devices in the same places, the same monitors and whatnot. But these people just drove their cars up, parked in a parking lot, and walked into this school room. So it was a laboratory, but it was set up in such a way that it was very similar to the actual ship control centers. So what they did then was give them simulations of like radar messages that were coming in, things like that, so that they could interact and react to those. So testing some variables that they were testing were like the stress that they had, how they worked together as a team, things that worked well and didn't work well for the command structure. So what they found out through interviews with those people is that even though they had just driven up to this school, that they had walked into a classroom, they felt like it was real. So it was set up so well that even though it was a laboratory setting, it seems like they got really close to natural observations. So in the back of their minds, they knew like they were in a study, but it seemed really real to them. Like they were all pretty stressed out by some of the things that were attacking them essentially in the simulation. So your behavior might be altered, but if you do a good job with a laboratory setting, you might be able to get really good data about behavior with a more controlled setting too. Surveys, answering questions about yourself, reporting on your own understanding, how you feel, your intentions to behave, or how you've behaved in the past. Interviews, one-on-one discussions, or with a group. A lot of times you can get a lot more in-depth information from those. Standardized tests are really similar in a lot of ways to surveys, except you can compare one person's score to another. And then a case study is looking at something unique about an individual or a group. So you might do a case study of one person who has a really amazing memory and look at them as a case for how do they have such an amazing memory? What's going on there? Or looking at the case of, say, a startup business that's doing really well as a case study. All right, so physiological measures, blood pressure, MRI, things like that. So we finished discussing all of those things last time. We'll start off talking about what descriptive research, correlational, and experimental research is, and then I'll let you break off into, honestly, with how many students we have right now, it might just be best to do one big group because only about half of the students are here right now. If we get more students in, we might be able to split into two groups though. But let's jump into talking about descriptive research. So descriptive research does, like the name implies, describes things. So you will be describing how the teams on the ships interact with each other. You might be describing how this person, the child, is building blocks. Maybe you can describe development a little that way as well. You might be able to bring them in when they're a couple months old and give them blocks and see how they interact with them. Then a couple months later, give them blocks, see how they interact. Maybe you notice one time and you describe that they were only able to stack 2 blocks on top of each other, but this time they came in, they were able to stack 6 blocks on top of each other. That might suggest something about their cognitive abilities as well as their motor abilities. So with descriptive research, you're using observation. You can also be using surveys. You can be using interviews, case studies, or content analysis. We haven't talked about content analysis. Essentially, it's looking at pieces of content, generally things like journals or newspapers. So like personal journals someone would write in. Looking at the content to try and figure out what was that person feeling or thinking. You might look at the journals of a famous artist. So like Van Gogh or something like that. I don't know if he actually kept journals, but you could look at the journals, do a content analysis, and maybe even try to tie some of those or describe how Van Gogh was feeling at the time he was painting certain pieces or over his lifespan. So you can use any of these tools to do descriptive research. You can also use a lot of those tools to do correlational research. So a lot of times when you're starting out studying something, you'll do some kind of descriptive research, or if you've seen some new kind of phenomena, you'll do some kind of research to describe what it is you're observing, what variables might be playing a part. And then correlational research gives you a lot better idea of how a variable is related to other variables. So you might look at the relationship between at least 2 variables. Let's use creativity and well-being. So creativity might have no causal relationship with well-being, but they might both be related to other things in a person's life. So maybe they are related to one another. So with this, when you're talking about a correlation between, say, creativity and well-being, statistically, we talk about it from -1 to +1. So your book gave a couple examples, but the positive and negative tells us the direction of the correlation, and I'll show some graphs and describe that in a second. And then how close it is to either positive or -1 tells us how strong it is. So if it's closer to 0, it's a really weak relationship. If it's closer to either 1 or -1, it's a strong relationship. So here's a couple different graphs. So let's look at this one. This is the strongest positive correlation here on this page. So this one, you might have a stat of positive 0.92 for this graph. Let's put some variables as an example. Let's use creativity and well-being. So what we see here is for one individual, each of these dots is essentially a person's data graphed on these 2 things. So this is well-being over here. This is creativity. So this person has both really high well-being and really high creativity. So they scored really high on their creativity survey, let's say, as well as really high on their well-being survey. Versus this person over here, they scored quite low on their well-being survey and their creativity survey. So each of these is one person's point on both well-being and creativity. So just graph together to meet. And so what you can see from this is in our sample that we tested, it looks like there is a strong positive correlation between creativity and well-being. So if you saw something this dramatic, you might say, well, there's got to be some kind of causal relationship here. Maybe some other variable is causing both of these, or maybe creativity is causally related to well-being or something like that. Or maybe when you have higher well-being, you also have higher creativity. So it might suggest that. But with correlation, you can't know what the cause is. So we don't know why both of these are related. We just know that they are. We just know that they are closely associated with each other. This is an example here. If you drew a line of best fit, this is a negative correlation. So 2 variables, let me think of 2 variables that shouldn't be negatively correlated. Or there's not a causal relationship, but maybe a correlational relationship. I can only think of causal examples right now. I should have prepped. I think the next slide actually has some from your books. but those ones are pretty causal as well. So I'm trying to give an example of something where you might find a negative correlation, but it wouldn't be causally related. So in this case, variable 1 is high while variable 2 is low. So variable 1, let's use creativity and well-being again. So let's say this is again well-being scores, and this is creativity scores. If we saw something like this would suggest this person has really high well-being, but feels they have really low creativity, versus this person has really low well-being, but really high creativity. And this one's about middle on both well-being and creativity. So if we saw this, we would say there's a pretty strong negative correlation. So you can see the spread of the data here around this line of best fit is a little wider. So the wider the spread, the lower your correlation is going to be. Here it's a very tight spread. So this would be like a positive 0.92. This might be a negative 0.70. So it's a little further away from the 1. So it's a little weaker correlation. And then this is a good example of having essentially no correlation, no relationship. If you asked a computer to find a line of best fit through here, it probably could. Maybe it would give you the line of best fit this way, and it would say there is a weak positive correlation, maybe a positive 0.05. That would be a really weak negative or really weak positive correlation, essentially showing that there's no relationship. So in this example, if we use those same two variables, well-being over here, creativity over here, say, well, this person here has really high well-being, but really low creativity, versus another participant had about the same level of well-being, but very high creativity. And then this person had about middle of the range creativity, but very low well-being, versus this person had about middle of the range well-being and middle of the range creativity. So you can see the data points are kind of all over the place. So the variables don't seem to be related to one another. You couldn't predict one based on knowing the other. Versus here, if you knew someone's creativity, you'd probably know their well-being or a pretty close guess of what it is. You could predict it pretty well. So that's what you do with correlations. You try to find relationships between the variables, see how they're related to one another. Can you predict something else based on knowing one variable? The stronger the relationship, the easier it is to do. The weaker, or when there's no relationship, that makes it really difficult to predict something from knowing one other variable. So some other examples, and again, some of these are causal examples, so one is causing the other thing. Correlations don't tell us if there is a cause, though. So here's an example of a negative correlation. So level of attentiveness, high level of attentiveness, and then the length of a lecture. So your level of attentiveness is higher when a lecture is shorter, versus if the lecture is very long, your level of attentiveness, maybe we should correlate the number of mistakes I make in speaking and your level of attentiveness. I think that might be an interesting graph. Again, maybe causally related, or the number of self-depreciating jokes I make and your level of attentiveness. That would be a good one too. So that would be an example, though, of a negative correlation. So as one variable is high, the other variable is low. Positive, they're both, as one goes up, the other is up too. So high and high, low and low, versus here, one variable is high and the other variable is low. And then over here, it's flipped. So this variable is now low, this variable is now high. So positive correlations, yeah, negative correlations. Let's look at an example that really demonstrates that correlation is not causation. So this is not the actual graph. The actual graph is a little wider for this finding. But there is a strong positive correlation between ice cream sales and violent crime. So it's not quite this strong. This is just an example graph. The actual correlation is about positive 0.72 for the correlation between ice cream sales and violent crime. So ice cream sales are not causing violent crime. Violent crime is not causing ice cream sales to go up. So what is causing both of these things? Or what do you think is causing both of these to be related? What's happening here? So either type your answer in the comments or feel free to raise your hand and you can take over the microphone. Oh, sorry, I was muted that entire time. So we've got a comment. Correlation does not equal causation. Exactly. So what might be causing these? So we do see that they're related to one another, and this is a real finding from research. What is happening? What is causing both of these variables? Causing the ice cream and causing the violent crime. So someone might be typing it right now. So feel free to keep typing it. But let's keep moving forward. The thing that's actually causing both of these variables is heat. So in the summer, we tend to see that people, when it's hotter, they tend to do more violent crime. So maybe they're more mad or frustrated because they're more warm, as well as it gets warmer, we see more ice cream sales. So the heat is causing both of these variables to change. So we see a correlation between the variables. Ice cream sales, when they're high, instances of violent crime is also high. When it's very cold, there's less ice cream sold and there's less violent crime. So we see a strong positive correlation, or a reasonably strong positive correlation, between violent crime and ice cream sales. But the ice cream sales in no way is caused by the violent crime. The violent crime is not caused by the ice cream sales. Both of them are caused by something else. So just like Rachel said, the correlation between ice cream and violent crime does not mean that there is a causal relationship. So correlations, they can give us these relationships, and sometimes they might even suggest that there might be something causal there. So like our examples on the previous page, some of these might be causal in these examples, like the attentiveness and the length of a lecture. There might be a causal relationship there. But a correlation in and of itself just tells us that there's a relationship. So that's something that'll be on your exam as well as your final exam, actually. So hopefully that's something you understand a lot better now. So the way that another interesting, at least I think it's an interesting finding. Another interesting finding is that there is a strong correlation. Never mind that. There's other interesting examples of correlations being thought of as causal in history. I guess I'll go over it really quickly. So there is a strong correlation in the 30s. We saw the 1930s. It's almost the 2030s now. Crazy. So in the 1930s, we saw a correlation between marriage rates and male suicides. So the researchers at the time, they actually interpreted that correlation as a causal relationship. So it was an error, though. So they were saying, their explanation was that, well, the men can't get married, so that's why there's higher rates of suicide. In reality, there was something else happening in the 30s that led to both those variables. So it was the Depression. So people couldn't get work, they couldn't afford to get married and have weddings and support a family. They also couldn't work and support and feed themselves. And so it's a really dark example. So sorry about that. But it is an example of, in the research, they described this correlation as a cause. They said one of these is causing the other, but in reality, a third variable was causing both of them. So there was a strong correlation between the marriage rates and suicide rates, but they weren't causing each other. But the original researchers did interpret it that way, and it wasn't for like 15 or 20 years that other researchers said, oh, hey, they made this really significant error. This was not a cause, this was a correlation. So even researchers can make that mistake. Sometimes I might even use kind of causal language in saying, like, in the way I'm talking about things. So the kind of research we've got to do to determine cause, though, is an experiment. The experiment is the only way you can really reliably determine a cause. You can use a quasi-experiment as well, but for this And you can use longitudinal research too. But for purposes of this class, let's focus on just experiments. So experiments, you need at least two variables, and then you manipulate one of those two variables in order to determine that the variable you changed and you manipulated affected the other variables. So let's use the example here of test scores as one variable and music or noise level as another. So we've got a group of students studying or taking a test in a quiet room. You might say that's your control group. And then you have a group of students taking the test in a loud room where there's a brass band playing. So that's your experimental group. So you have your two variables, music or noise level, and your second variable is test score. So you want to see, or your hypothesis might be that when they're in a quiet room, the test scores will be higher. So let's say we take a whole high school of, say, 600 students, and we give them the same test. So with that, we'd have, of that 600, we'd have about 300 in the control group, about 300 in the experimental group, and then we would average their scores and see, so which group on average had the higher score. That would suggest something about causation. So did the music level, did having a brass band or did having a quiet room, did that lead to higher or lower scores on average? And since you have a group that big of 600 students split up into groups of 300, you could probably get some pretty good causal data there, as long as you didn't have, say, all of the better test takers in one group than another group. So there are other variables to be concerned with, of course, but just at its basic level, you need two variables, and you need to manipulate one and see if it changes the second. So some terminology here. Independent variable, that is the IV for short, independent variable. That is the one you as the researcher manipulates. So in our example, we're manipulating the music, so whether there is music or not. So that's the variable we're manipulating. That's our independent variable. The dependent variable, you can think of it as kind of your final measured variable, and it's the one that you're wondering, does it change based on the independent variable? So the dependent variable is dependent on the independent variable. So in this case, it's our test score. So it's our final measured variable. So does our manipulation of music, does that change the test scores? So IV, DV, will be using those terms a lot through the class, so hopefully that gives another example. We have a couple more coming up too. So for this, you need at least two groups to test it. You need at least a treatment group and at least one control group. You can have more groups, you can have additional variables, you can have multiple independent variables, you can have multiple dependent variables. It's a little easier to have more dependent variables. It's a little harder to have more independent variables because then you need a lot more groups. So let's say, for example, we wanted to test 3 levels of our independent variable. We wanted a brass band, we wanted a soft, like instrumental music, and we wanted a quiet room. You could do that, but you would have to split your 600 people into groups of 200 now. So one group of 200 has quiet room to take the test, one group of 200 has quiet music, and the other group of 200 has the brass band while they take the test. So that is still looking at one IV, the music type or music level or noise level, and the DV of the test score. You have a couple different levels. So you can do it in a lot of different ways, but at the very minimum for an experiment, you need 2 groups. So your control and your treatment. So this little diagram kind of suggests what you want to happen in random assignment. So for those 600 students, whether you're splitting them into 2 groups or 3 groups, you don't want to end up with one group having all of the really good test takers. If all of the really good test takers were in one group, then your result might just be because well, they were all just really good test takers, no matter if they had the brass band or a quiet room. So you want to split differences between all the groups as evenly as possible. That's called random assignment. So here we've got just one difference between the group. We have purple people and orange people. So when we split them up into groups, we have some orange and some purple people in this group, and we have some orange and some purple people. Purple people is one, funny to say and fun to say, but kind of hard actually to say. But we've split that difference between these 2 groups. So you can use that as an example for genders. So you split genders evenly between groups. Ethnicities, you want to split ethnicities between groups. how good you are on taking tests. You want that split evenly between these two groups. Honestly, that one's probably most important for this specific example, because you don't want everybody who's really good at taking tests in one group than another group when you're checking their test taking scores in the end. So randomization reduces the likelihood that the results come from that already present difference, like the already present difference of some people are better at taking tests than others. So you want to have a valid study, you want to have valid data, and that's called experimental validity, to make sure that you can attribute the cause to your independent variable. So again, you want to be able to say, yep, the quiet room caused a better test score than the brass band. You don't want to be in the end analyzing your results and say, oh no, everybody who was a good test taker was actually in the quiet room, so maybe it was just because they were all better test takers. Then you've failed as an experimenter in that case, and you'd have to redo it. So questions about experiments, examples that you wonder, does this fit an experiment, or which is the IV, which is the DV in this kind of case? Let's give another example I just thought of because I saw a family member carrying a cat. You could do a similar kind of thing where you test, do kittens or puppies lead to higher well-being scores? So for your dependent variable, you would want to measure well-being. So maybe for well-being, you have people complete a survey and you get maybe a physiological measure, so like a cheek swab to check their hormone levels. So you would get a random sample of, let's say 400 people. That's a pretty large size sample, good enough for this experiment. And then so for each of those people, you would maybe ask them in a pretest, you'd say, hey, do you like puppies or do you like cats? Just to give yourself something that you can statistically control for later. And then no matter what they say, you just randomly say, okay, you're in the puppy room or you're in the cat room. So you randomly flip a coin or randomly assign people to those groups. So you have a group of 200 people in the cat group, or about 200, because you're randomly assigning. You might have like 205 versus like 195 or something like that. But that's just flip a coin, right? So you have about equal numbers of different genders in one group, about equal numbers of the different genders in the other group, about equal number of people who like dogs and who like cats in each group. You have equal number of ethnicities and socioeconomic statuses in both groups. And then you test, well, what's their happiness level? Was the group in the cat room or the kitten room versus the puppy room? Which one had a higher average score on their survey of happiness? Which one had higher average levels of oxytocin in their blood or something like that. So again, your independent variable is the pet, what kind of animal they were exposed to, and then your dependent variable is their happiness or well-being level. So another example, hopefully that makes it pretty clear what an experiment is, what you need, some of the basic features of any experiment and a good experiment. Again, the larger group you have to sample from, the better your groups or the more representative they will be. So if you want to say something about the whole United States, but you only sample, let's say white men, like a bunch of original psych studies did, you're not really going to be able to generalize to all people in the US, especially since it was really white middle class men in a lot of early studies that were the only sample looked at. So that depending on what you're finding, you might not be able to generalize. So you do want to sample from as close to your population as possible. So if we wanted to sample the entire population of Salt Lake Community College, we might randomly select every 10th person on the whole student roster. We'd get a pretty good random sample that way, and then you could, from that sample, then randomly assign to different groups. So you want to get a sample that's as close to your population as possible to get better data. But some of those points are probably more than you need for this class. I like research methods, so I teach a whole class on it. So there's so many different points. Like I could talk about any of these points. I mean, that's really for all these psych subjects though too. All right, so longitudinal and cross-sectional designs are specifically developmental research designs. They're really good at figuring out how people change over time. So cross-sectional is the first one we'll talk about. So let's say we wanted to look at how people with autism, what their life is like over time. So we could take a cross section. We could maybe take some 5-year-olds, 10-year-olds, 15-year-olds who've all been diagnosed with autism, and I could go today, meet with all of them and interview them all. So get a sense of their lives, probably interview their parents as well, see what kinds of challenges, what kind of supports, what kind of things help them, what they think of their own symptoms and autism itself. So I could do that all today. So at this one point in time, get a cross section of information from different ages. So I've got the 5-year-olds, the 10-year-olds, the 15-year-olds. So that's a cross-sectional study. And from those findings, I might say, okay, so it looks like by the time they get to 10, they understand their diagnosis at this point, or maybe by the time they get to 15, they've settled into how to do school, like strategies, things like that. And I might infer that that is a developmental change. But there's problems with that too. So the people who are 15 today went through different experiences when they're in elementary school than the 5-year-olds or 10-year-olds did, right? So my children who are going into elementary school now, they're going in during the coronavirus pandemic. So that is a difference that they're experiencing versus what I experienced versus what a 15-year-old experienced in elementary school. So those kind of history effects can affect these kind of cross-sectional designs. So you might be able to get good data, but depending on what you're looking at, those kinds of history effects might affect your findings. So what developmental scientists like the most is longitudinal research. So you could think of longitudinal as long. So it's a long study. You take that same sample, so one group of people. So I would go today and find 5-year-olds who've been diagnosed with autism, interview them today, interview their families today, and then follow them for a long period of time. So those same individuals, and I measure them again when they're 10, and then again when they're 15. So that's a longitudinal design, following them through time. So with that, you'd be able to have the same history effects for all those participants. They're all going through the same time periods of history. So that isn't an effect. You can oftentimes see better and even causal changes in things with a longitudinal study. With this, during that longitudinal study, I might use interviews. I might use surveys as well. I might look at other data that exists at this point in time. So you can use lots of different data collection methods for a longitudinal or a cross-sectional study. Longitudinal gives you a little bit better developmental data, but you do have the weakness that if I start this study today, I'm not going to have all my data from 5, 10, and 15-year-olds for another 10 years. I've got to follow them along. People will drop out, people will move, things like that. Some people might die. So with that, there's that weakness of longitudinal designs. So with that, it is generally considered the more rigorous kind of study. You can put them together in what's called the sequential method. So let's say today I measure both 5 and 15-year-olds. So I go interview them, give them surveys. So I've got a sample of 5-year-olds, I've got a sample of 15, and I can maybe make some inferences, say maybe some of these changes are dependent on the development. But then I follow them again 5 years from now. So I now have a sample of 5-year-olds, 10-year-olds, 15, and 20-year-olds, essentially, right? And then I follow them again for another 5 years. So I've got 5, 10, 15, and at 15 they overlap, and then 20 and 25. So then I've got a really long period of data, and I've followed the people for part of that time. So I've got some overlap, so that makes it helpful to say, well, yep, these are developmental changes over time because this participant is like this participant, those kinds of things. So that's the sequential method, combining those two. And it has some of the same strengths and weaknesses as both of its compared as longitudinal and cross-sectional, but it kind of gets rid or overlaps some of them too. So longitudinal is seen as the best, but we do have cross-sectional as well as sequential, putting them together. So questions about those, or when you might use one versus the other? So one reason sequential method is used, I think, is primarily because of the system that we work in as researchers. So most of us are in academia at universities. Generally, researchers at universities are required to publish X number of papers per year. So if you're following a sample longitudinally over 15 years, you might not have that final data set to say much about for that whole 15-year span. But if you can do something like a cross-sectional or sequential study, you might be able to get some data now, be able to get a publication out, even if it's not as good as one that you're waiting multiple years to get the final data on. So also funding, it can be hard to get funding. For example, one of the studies that we started, well, let's say you want to do a longitudinal study, but you might start with requesting funding from granting organizations to do something just right now. So you can get some publications out. You can say, hey, this group funded me. So John Templeton Foundation has funded a couple of the grants that I've worked on, for example. And they like to see, well, what kinds of data has come out from our results. And you do quarterly reports. So if you're doing a longitudinal study, your quarterly report might be, hey, we're just waiting. And they don't like that as much. So that it's kind of the system that we're in, that we're baked into, is some of the reason that longitudinal is not always done as much as maybe it could be, because it is the best, but also with the limitations we have in the system. Yeah. All right. So those are a couple different research designs. We talked about descriptive, correlational, experimental, longitudinal. Now you've got enough information about how to do studies that I think as a group, we've got enough participants here. I think we could probably break into 2 small groups. Well, then we'd have just small group of probably 3 and 3. And I think that's fine. So let's basically alphabetically. So we've got a couple different people. Let's say if you're the bottom 3, so last names of Corey Jarvis and Halams, all of you jump into this small teams room. So this IDQ one, even though I think that doesn't actually fit all of your names. And then the top 3, so if you open up the little participants, so here, all these 3 students, so we've got Brady, Caitlin, Mackie, all in group 1. So click over here to teams, choose this group, and again, sorry if I messed anybody's names up. I forgot to pull up my notes of how to pronounce all the names. So my mistake, and I will not do that again. So Nicole, Rachel, and Tamara, I believe is how yours was pronounced. So Nicole, Rachel, and Tamara jump to, oops, wrong one. So teams, jump to the I through Q. So let's jump there, and we'll have some small group meetings for about 15 to 20 minutes. So at 11 o'clock, we'll be back here in the main group meeting, and I will basically jump back and forth between them as we do this thing. So there are 3 possible questions you and your group can answer. So question 1, how does empathy impact sharing behaviors in children? So as a group, you would say, okay, what variables do we need to look at? What participants do we need? What kind of methods are we going to use? Are we going to do surveys, or is it going to be longitudinal? Are we going to do interviews? Is it going to be cross-sectional? Things like that. Are we going to do an experiment? So for question 1, if that's the one your group decides on, figure that out. And then question 2, how does ADHD present in adolescents versus adults versus late adulthood? So probably one of the developmental designs would be best for that. And then 3 is, does weather at the time a person is born, does that affect their personality in childhood, adolescence, or adulthood? So how would you study these things? What kind of variables would you look at? Would you do something like a longitudinal study? Would you do an experiment? How many variables? Would you do surveys? Would you ask parents to be involved? Things like that. So do your best to make your own study based on these questions. The first step is deciding which research question you want to do it on of these 3, and then figure out what variables you would need to measure, how you would get groups, how many would be in your groups about, and imagine you have unlimited access. You have consent from all parents for anyone under 18. Imagine you can measure everybody in the world or as few people as you want, and you have unlimited funds. So jump into your small groups and we'll get this started, and we'll be back here at 11.
Sorry, real quick.
Yeah, go for it.
Could you remind me which group area we were going to?
Yeah, definitely. So I'll show you again. Go. So Kaylin and Mackie will all click on basically the Teams icon and then go to this classroom group last name A through H. So click on that and then you can just start a new meeting there. And similar for, let's go back here. Similar for Nicole, Rachel, and Tamara, click on Teams and then go to this one, the I through Q group. And then click Meet. If you don't have a microphone, you can do chats in the chat box, but hopefully everybody does have their microphone and their video as well. So we've got 6 students in here right now, so hopefully we have this group of 3 and this group of 3. All right, get to it. All right, everyone's starting to file back in, so that's good. We'll wait till we see more students jump in. And then I think we had a volunteer to share their idea for their study. And so basically just which question your group decided on, and then how you were going to go about. I think before I left your group, Nicole was volunteering to do that, but it might have been a couple of you in that group. So go for it. Take over the mic and share what you decided for your study.
Can you hear me? Okay. So we chose the question, how does ADHD present in adolescence versus adults versus late adulthood? And we decided to do experimental research. And so we were planning on just taking a bunch of people from different age groups and splitting them into a treated and controlled environment. And the treated environment, they would receive medication that would help to focus, like help people who have ADHD focus more. And then the controlled wouldn't have any medication at all. And then we would give them a task, and we were thinking like a puzzle or something, but the puzzle would be like for adults, it'd be a bigger puzzle than it would be for kids, just because then it'd be kind of like the same type of focus you'd have to focus on, and then see how different they would focus compared to people with medication and without medication.
Yeah, that was a really fantastic idea. So I hadn't even considered doing an experiment when I was putting up these questions. So I thought it was a really interesting solution for seeing how it presents at the different age groups. So getting one, you've got the different groups of different ages. Two, you've got the treated group and an untreated group to see how it presents differently in all those different subsections of the population. So really clever idea there. The other group also had some really good ideas. It sounded like they were going to do a cross-sectional study of different age groups as well. So some good developmental ideas coming out there. Some ways that with each of these methods, there was debate in both groups of, well, is this better for this or is this better for this? And that's kind of what researchers do at all times is we have our question, hey, what does ADHD look like in adolescents, adults, or late adults? And then we have to decide, well, which methods work best to analyze the exact variables we're most interested in. So the different ideas from the two different groups I found were really interesting to give us two different ways to look at that. So another way that it could have been done is with a longitudinal study, taking adolescents or maybe even finding children who are diagnosed in childhood and following them all through their lives, doing surveys and interviews throughout their lives. But that experiment idea is really good. A cross-sectional study is really good. You could even combine those, do that cross-sectional and change it to sequential, or do that experiment and have it be a really long experiment. So say a 3-year experiment, you have maybe 4 different kinds of drugs that are being tested, as well as a control group at these different ages. And so for each of so you've got a group of adolescents who is on drug 1, 2, or 3, or no drug, a group of adults on drug 1, 2, or 3. Then you follow them for 2 to 4 years or something like that and measure them at different times. Because most of the ADHD drugs, you probably didn't know this, but most of the ADHD drugs take a couple weeks to start working really well. A lot of medicines for different disorders or things take a couple weeks. It's not like Advil where you can take it and relieve pain usually pretty quickly if it works. But yeah, so really great ideas, and I like to see the creativity. Also, some of the struggle from both of the groups was, well, we don't really know like what kind of assessments do they have for ADHD, and that's definitely a weakness of trying this in some of your first classes in psychology. There's things you don't know about the field, so you're trying to decide, is it realistic to go this big or this small? Like, should we assess people all over the world or in different climates? In one of the groups was trying to decide. So all good things to discuss and debate, and was what researchers would be doing and looking at what had been done previously, which is obviously something that you didn't do up to this point. You just learned about these methods and threw out some that you thought would be good. And I think both of your groups came up with some really good ideas. So way to go with that. So it seems like the activities worked pretty well. People were able to get into the groups as well. So just logistics wise. So good. I'm glad that worked out pretty well. It's always funny too to see how much more time it takes in a classroom to like split off into desks of groups or something compared to online to just do click over to groups. It always somehow takes so much longer to do it in this kind of online environment. All right, so the next thing we'll be talking about, and I don't know that we'll be able to get to the actual beginning of chapter 2, but it'll definitely be all of next lecture, is ethical research. So I want to give a couple examples of when psychologists have not done ethical studies in the past, and then how that has changed what we are doing today. So we'll watch this little YouTube video. About 30 seconds into it, let me know if you're having any trouble seeing or hearing it, because you should be able to both see and hear it. I should be sharing it right now, and then you should be able to hear it as well. So about 30 seconds in, if you're not able to, definitely let me know. Of course, my speaker decided that this moment is the exact moment it wants to die. I'm trying to replug it in, see if that helps. Oh my goodness. Of course, and I just put my extra speakers, in case this ever happens, away in my garage. Oh, well, that's exciting. All right, well, I will just scroll through and talk about some of the studies that were done. So one study that was done is called the Little Albert study. Sorry this isn't working. I will definitely get better speakers that don't do this ever. But hopefully you can hear me. So the Little Albert study essentially tried to condition a human. So we knew that we could condition animals to pair a stimulus like meat with an unrelated stimulus like a bell or a metronome, and that by using just the bell or the metronome that you could make the dog drool. So essentially what was done was you had this baby, a 9-month-old baby named Albert, and you would present a rat in front of him. And then while the rat was running around, they also presented like a bunny, a cat, a couple other animals, stuffed animals as well. When the fluffy white animals were out in front of them, they would bang a metal bar behind little Albert's head, like not hitting the child, but making a really loud noise and scaring it. So the child did start to associate the fuzzy white objects with a loud noise. So it was conditioned to be afraid of white creatures. With that being said, they never reconditioned him to not be scared of the creatures. It's also not clear if they got informed consent from the parent. And they only did this experiment, which you can tell is not really an experiment, with the one individual. So, I mean, I am glad they didn't try to screw up more children for an experiment, but they definitely should have got informed consent, told the parent what they were going to do, tried to help the baby not be scared of white creatures for the rest of its life. So that's an example of an unethical study where not much care was taken in the individual's to the individual's safety. The other one, I really wish we had the video because I can describe it, but seeing it on video with the audio would be better. All right, so the other study I want to talk about is the Milgram study. So the Milgram experiment, you might have heard this before. It's often actually described like in news reports when there's talk about like, why did these people do these bad things? You might hear of like just following orders. A lot of this was studied with the Milgram study. So Milgram was wondering, well, maybe had the hypothesis that maybe people do bad things because they're told to by an authority. They're just being obedient to an authority. So you had an experimenter who wore a white lab coat, who brought in a participant, a volunteer, to be a part of a study, and so they were they were being a teacher in this experiment. Then you had a learner who the subject thought was another volunteer. So they thought they were another volunteer, but it was actually either a paid actor or, as you'll see in a second, a recording. So the learner would have a desk, have questions, and have an electric shock generator. And when the learner got a question wrong, they were in another room. The teacher, the actual participant, would give them a shock or think that they were giving them an electric shock for getting a question wrong. So the participant that was actually being studied thought that they were shocking a person. And as they went up in shock levels in this learning experiment, the experimenter would say things like, the experiment requires that you continue, or there's no permanent tissue damage, please continue. They had a standard kind of canned responses that they would say when the participant would kind of protest, because almost all the participants were like, this doesn't seem right, I shouldn't do this. And the experimenter in the white lab coat would say, the experiment requires that you continue. At some point, the learner, which was either an actor in the other room or in many cases a tape recording of responses, would start protesting louder, bang on the walls, say they had a heart condition, and then at some point just stop talking at all, as if maybe they had died. So many of these individuals thought that they might have just killed a person, and the experimenter is saying, nope, just keep doing the questions, keep shocking them. So they weren't actually shocking anybody, but they didn't know that. The participant didn't know that. They didn't find out about that after they were done either. So many of these people left thinking that they just hurt somebody. So that's obviously not great for someone's mental well-being. So it did teach us a lot about obedience to authority, that just by having some authority figure in there saying, hey, keep doing this thing, people did do something against their conscience. But it also showed a lot of people in just the general population, they were really surprised about this, and they were really upset that care wasn't taken to let the person know what happened afterwards, to make sure the people were okay. Because again, it was either a recording or an actor. Nobody actually got shocked. But it's not mentally very healthy to think that you just hurt someone really badly. So because of that, we have created some ethical guidelines. It started with the Belmont Report, and similar things were happening in medical research at the same time. There were a lot of unethical studies done with people in medicine too. So around the same time as it was happening in medicine, it was happening in psychology. And so the first was the Belmont Report, and that was some ethical guidelines. Now we follow basically the APA's ethical guidelines. And any institution that receives any kind of federal funding, even if it's not for psych studies specifically, if you get federal funding for other kinds of studies, even history, you still need to have an IRB, an institutional review board. And what that will do is you will propose your study. So your two groups, you just came up with a study just a moment ago of what you would want to do to study these developmental topics. You would propose your study to the IRB and say, hey, this is what we plan to do. This is how we're going to interact with people. This is how we're going to keep them safe. This is the data we're going to collect, how we'll keep the data safe. This is the informed consent form that we're going to give them. So the IRB will look over that, make sure your plan is to be ethical and appropriate and keep people safe. And then they'll either approve your study, or they'll say, hey, fix these things, then try back, or they'll say, nope, not at all. This is a very bad idea. So if you tried to do Milgram's study today, they would probably just outright reject it rather than make changes. I've had most of my IRB times, they've come back and say, hey, change this about it. So change some like even specific wording in a consent form. So they're really thorough. So make sure your wording is this specific so that it's really clear for people. So that's usually what I've gotten like back and forth on with IRBs. So they can do a really good job. But again, that's to help protect before a study's done. After you're trying to publish a study, you go through a journal and you say, hey, I think that this would fit your journal. will you review this? And so they'll send it to other authors in the field, which as well as looking for, is this a good study? Does this have good new data that we should publish? They'll also say, hey, you actually did something. They could, if you did do something unethical, say, hey, you're letting people know too much about where you got this data. People could find these participants, that kind of thing. So some of the main, this isn't all of the things you've got to worry about with a study, but these are some of the main ethical concerns. One is informed consent. So consent is just agreeing to do a study, but you need to have informed consent. Let people know what they'll be involved in. So in my consent forms, I say, hey, you're going to be doing this survey. It's going to take about this much time. It'll be asking questions about creativity, well-being, purpose in life, things like that. I'm really clear about that. With informed consent, if you are trying to use deception, so put people in, say, control groups and treatment groups, I've done that before, and I don't tell them, hey, you are going to be in a treatment group, or you are going to be in a control group. I will tell them, hey, you might be in a control group, you might be in a treatment group, both groups get these kinds of activities. And I'm a little more general, and that's all right with the IRBs, and that's as much deception as I've ever used, and I would feel comfortable using with participants. But then afterwards, I definitely let them know, and that's called debriefing. So you were in this group, this is what it was about. This is any information you need to know about yourself from your scores, things like that. So if you're doing a medical study and you tested people for cancer, you'd probably want to give them their results, right? So that kind of thing. Confidentiality is making sure all data is confidential. So when I publish a study, I make sure that the participants are not able to be identified from what I publish, unless they've agreed to it. So I do have one study where I'm interviewing heroes we're actually videoing them and putting it up like on a website. So they're going to be identifiable. It's got like their name under it. There's a few that don't. And so all identifying information is taken off as well as best we can. But only in special circumstances is that possible. I shared data the other day with another researcher who wasn't part of the immediate team for some data I had collected from high schoolers. And I deleted everything that could possibly tie those participants to where they were, because I was following them longitudinally. So I had to delete their emails, any kind of identifying ethnic information. So like gender, ethnicity, those kinds of things, just so that it couldn't be tied back to the people. Debriefing is definitely making sure participants know what the study was about and that they are leaving with good feelings. So if it was a challenge, if it was a struggle, if they think they might have shocked someone to death, let them know that they didn't. Also, it's really good in debriefings to give them some skill. So when I do studies on cognitive capacities, giving them a new cognitive skill or like a mnemonic, like teach them that, that's a good thing for debriefings too. And then deceptions, basically try not to use it unless you absolutely have to. So, and then make sure the IRB does have to approve it as well. So that is chapter 1. The main point of all of this is that we have all these tools to gather data to answer questions. And as an applied researcher, especially in lifespan development, generally we're trying to help people's lives improve and help people thrive. So whatever risk factors they have, we can maybe even work around them or work through them to help people live good lives. So you have any problem that you can think of, maybe it's poverty, maybe it's not being able to pay attention because of ADHD, and then you do research to try and solve that problem. You use the theory you have, the methods at your disposal. You get out in the real world with people trying to work on it. You see what's being done by people, professionals as well as paraprofessionals. What are people trying to solve poverty or help people with their attention? And then with what you find, you deliver that back to policymakers, maybe to journal articles, to more evaluation. And through this cycle, hopefully, you can solve some of those problems. So that is the point of all of these basics that we've talked about. And next time we come to class, we will jump into chapter 2 and talk about some actual like prenatal developmental studies and things that we know about prenatal development because of these kinds of methods and research. So thank you all for being here. I'll stick around for a minute or two if you have any questions. Definitely let me know. I know a student was mentioning that they weren't sure how to get into the Teams recording at the beginning. Rather than like calling you directly, I generally do that at the beginning of class. But if I don't, you can always come here to general and click the join meeting spot. Looks like someone else started a second meeting at some point, and that's still going. But this is our meeting, so click join, and that's how you can join a meeting, even if you don't receive a direct message call. So yeah, thanks for being here today, and have a good rest of your day.